Hi everyone, today's lesson is on the product quotient rule. I'm going to go through a lot of problems and I'm going to skip a lot of steps to make the video a little bit shorter, but I'm going to post a PDF of all the problems that I do in the video and I'm going to show all the steps. So if you need extra help, hopefully that document will help you. Okay, so 2 rules today. Well, 3, we'll get to the next one later. The product rule says product multiplication. The product rule says that if you have 2 functions that are differentiable, function u and v, then their derivative is u times the derivative of v plus v times the derivative of u. You'll hear me say a lot, it's uv prime plus vu prime. Again, it's in the book, and these are things that you're just going to have to memorize. They're differentiation rules. There's a couple more to come later this week and later next week. Okay, there is the quotient rule, and I caution you. The quotient rule is v, which is the denominator, times the derivative of u, which is the numerator, minus, and this is why order matters because it's subtraction, minus the numerator times the derivative of the denominator, all over the denominator squared. So it is v u prime minus u v prime all over v squared. The key here to remember is that you take the derivative of the numerator first. So I'm going to do a couple examples and we'll go from there. So why would you want to use the product rule when you can just find the derivative by multiplying out? So what I mean by that is, if I give you that you have some function that's differentiable, and let's say it's like x squared minus 6 times the quantity 2x minus 5. You could use the product rule for this. For certain functions though, I would just multiply this out, which would give me 2x cubed minus 5x squared minus 12x plus 30, and then I would differentiate it from here. So the derivative with respect to x is 6x squared minus 10x minus 12. Why would you want to use the product rule? Because sometimes the product rule is easier. So I'm going to do the same problem using the product rule, and we should get 6x squared minus 10x minus 12. Okay, so I'm going to say let u equal x squared minus 6, sorry I'm in your way, and let v equal 2x minus 5. So the derivative is going to be equal to x squared minus 6 times the derivative of 2x minus 5, v prime, I'm showing some steps for this problem, plus v, which is 2x minus 5, times the derivative of u. Okay, so this becomes x squared minus 6. The derivative of 2x minus 5 is 2. The derivative of x squared minus 6 is 2x. So you have 2x squared minus 12 plus 4x squared, and that's going to give you 6x squared minus 10x minus 12. So these are indeed the same. Which way is better? Personally, I would do it this way, but sometimes the multiplication is way too long and finding the derivative using the straight power rule is not always your best bet. Okay, so I'm going to do a couple examples of the quotient rule. So if you're following along, this is number 20 in the book. This is number 20 in the book. And they give you that y is equal to 1 minus x, 1 plus x squared to the negative 1. Why can't I just use the product rule and take the derivative of 1 plus x squared to the negative 1? And that's because it requires a property you haven't learned yet. So we're going to stick with the quotient rule. So this is going to be find the derivative of y in terms of x of one minus x over x squared plus 1. Okay, so again, I said I was going to skip some steps. I'm just going to set it up for you. The denominator, which is x squared plus 1, times the derivative of the numerator. Okay, so this is prime, not first power, minus the numerator times the derivative of the denominator, all over x squared plus 1 squared. Okay, so when you multiply this all out, you end up with, again, there'll be steps on the PDF. You end up with negative x squared minus 1 minus 2x plus 2x squared over, x squared plus 1 squared. Combine like terms, this whole thing ends up being x squared minus 2x minus 1 over x squared plus 1 squared. Let me get out of your way. So in the big picture, I think what's going to be the hardest is that you don't make careless mistakes and that you remember take the derivative of the denominator, take the derivative of the numerator, which one comes first, etc., etc. Again, I have to be a broken record. You wouldn't have missed me. It's going to be on the PDF on Classroom. Okay, so number 24. Number 24 tells you, let's try that again, that the u of 2 is 3. This is the exact value. This is the exact value. That the derivative at 2 is equal to negative 4. And the exact value of the v of 2 is 1. And the derivative of 2 is equal to 2. Okay, so part A asks you to find the derivative of the product. Okay, so this is going to be u v prime plus v u prime. And you know all those values. This is a straight plug-in. So when you're all done with all of this plugging in, you should get 2. You know u, you know v prime, you know v, etc. Okay, part C asks you to find v over u. This is part C. Okay, again, this is just plug-in. So this is going to be u times the derivative of v minus v times the derivative of u all over u squared. You know all these values. You know that u is 3. You know that v prime is 2, etc., etc., etc. So when you're all done, this should equal to 10 ninths. When you're all done, that should equal to 10 ninths. Okay, I do want to go through part D in steps. I shouldn't have erased that. Shoot. Ugh, oh well. Okay. I'm going to write that down again because I'm going to need it. The u of 2 is 3. The derivative is negative 4. The v of 2 is 1. And v prime of 2 equals 2. Okay, I just needed that information. So I said I was going to talk about one more property in the video, and the property I'm going to talk about is the sum difference property, and you'll see why it's going to be super handy. So the problem asks you, this is part D, to find the derivative of 3u minus 2v plus 2uv. Okay. You can't just plug in that v is whatever they gave you. This is just saying a value of v. This is telling me that the exact value in v is 2. So I'm going to separate this using the sum difference formula, as well as use the property that says the derivative of a constant is just that constant. So, or not, the derivative of a constant is 0, but if you have a constant within a equation, we can factor it out. So hopefully all that gibberish I just said makes sense in a minute. This is the derivative of 3u minus the derivative of 2u plus the derivative of 2uv. Okay, so 3 is a constant. I can pull the 3 out. So this is 3 times the derivative of u. The derivative of u is u prime. You know u prime. It's negative 4. I'm going to factor out the 2. You can do that? Yes, it's a property. And this becomes the derivative of u. Well, you know the derivative of u. This is supposed to be a v, not a u. Let's try that again. The derivative of v, you know it, it's 2. And this is 2 times the derivative of uv. Okay, I erased it, but this just comes from part A. So now it's a plug-in. So this is 3 times the derivative of u, which is negative 4, minus 2 times the derivative of v, which is 2, plus 2 times whatever we got. I believe this is 2. This might be wrong. I might have it. I might be looking at the wrong place in my notes, so you'll have to double check. So this is negative 12 minus 4 plus 4, which is negative 12. Let me review some key steps. Some key steps in this problem is from here to here. And this is the sum difference rule. That's the sum difference rule that says if you're adding and subtracting, you can just not distribute. You can separate this into 3 separate derivatives. You're not distributing. You don't distribute a derivative. It's like you don't distribute a log. Remember those days? The log of x plus 6 does not equal the log of x plus the log of 6. A log is a function. It's not a word. It's a mathematical function. I mean, it's a word, but it's a mathematical function. Same thing here. You're not distributing the derivative. And then the other property is that you're multiplying by a constant. You can pull the constant out. You can pull the constant out. Last problem I want to go over is number 28. Okay, 28's a biggie. They want you to find the equation of the tangent line. They want you to find the equation actually for the tangent line at x is -1, I think. Yeah, at x is -1. Okay, so the first thing you need to do is find the slope when x is -1 on the curve. That's the first thing you need to know. So here we go. I need to find the derivative. I'm going to use the quotient rule. So this is x squared times the derivative of x to the 4th plus 2. I'm plugging into the quotient rule property. It's not really a property. Plus, it's a rule. X to the 4th plus 2 times the derivative of x squared. So it's the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over x squared squared. Okay, so for time and keeping the video a little bit shorter, the slope of the tangent line ends up being, when you find the derivative and you distribute and everything else, you get 2x to the 5th minus 4x all over x to the 4th. I would highly recommend that along the way of the video that you pause, do the work, and see that you get the same answer as me. Okay, so I want to know specifically at x is -1. So the slope of the tangent line when x is -1, the slope of the tangent line when x is -1, plug in and you get 2. -2 plus 4, yeah, you get 2. That's not the question. They want to know the actual equation. Okay, well, I have the slope. I need a point, but you have a point. At x is -1, when x is -1, plugging into the original function, I think we get 3, if I've done it right. Yeah, it's 3. So now I know my slope, I know a point. The point is -1, 3. The slope is 2, and you get 2x plus 5. There you have it, the product quotient rule with a little bit of the sum difference rule for fun.